Hello class, this is Mr. Hunter, and these are your notes on gravity and the constant acceleration equations. So in class, we're going to be practicing the motion graphs, and we're also that's going to springboard us, into the constant acceleration equations. But before we move on, I need to teach you a little bit about gravity. Now, when we talk about gravity, gravity is a force and we measure forces in newtons. We named the unit after Sir Isaac Newton, which he was a genius in his time, the precursor to Albert Einstein. And he discovered that the gravity that we have on Earth is the same gravity that keeps the moon in orbit around the Earth. It's the same type of gravity that keeps the planets orbiting around the sun. So he discovered that gravity is a force, and as a result, we now name forces, the unit for force is newtons. So a force like gravity causes an acceleration. Let me repeat that. A force like gravity causes an acceleration. Forces cause acceleration. Why? Because think about it. You push on the gas pedal in your car, which causes your engine to exert a force on the wheels, causes your car to accelerate. If I'm trying to make you go faster, I am pushing on you to cause an acceleration. So a force like gravity causes an acceleration. Gravity is an attractive force. It only attracts. So gravity is a force of attraction. It only pulls objects. It can never push. And that's actually the definition of force. A force is a push or pull. So there's different types of forces that we'll encounter. But the force that we really need to deal with now is the force due to gravity, because it's going to come into our calculations pretty quickly. And the reason why is because the force due to gravity actually causes, as we said, an acceleration. And you know what acceleration is. Acceleration is the change in speed over change in time. So in this case, the acceleration due to gravity, which I use the symbol A of g to let you know that we have acceleration and the g signifies the acceleration due to gravity. Your reference table uses the symbol g, which is totally fine. Uses the symbol g, and here's the key part. You have to remember it is an acceleration due to gravity, because we will calculate the force due to gravity, and that is something totally different. So the acceleration caused by the force of gravity is 9.8 meters per second squared. So when you are standing on Earth, you are experiencing this acceleration due to gravity because of the force due to gravity. Now, there's something here that I'm going to show you that's a little, I'm showing it you a little early, but it's really, really, really important that you get this. That's why I'm starring it. In this case, the word weight equals your force due to gravity. That is critical, and I cannot stress that you remember that weight equals your force due to gravity, because your weight is your mass affected by gravity. So it's mass affected by gravity. Will we use this immediately? No, we won't use this until the next unit. I'm introducing it to you now, so when I introduce you to it again, it will seem familiar. So you need to remember and know that weight is your force due to gravity. So when someone says, hey, what's your weight? One is we don't say pounds, we say newtons. But two is we say my weight is my force due to gravity. Now, that is all I need to show you, because we really need that number of 9.8 meters per second squared. Because now we get into these situations where we're still in one-dimensional motion, But we have these constant acceleration equations. Now, I mentioned this in class, so this is where I'm having you write this stuff down. In constant acceleration, the next three equations that I'm going to show you can only be used under constant acceleration. What does constant mean? Let's see, let me finish writing this down. So constant means, another word you'll see is uniform. So like Regents says uniform. So it would say like uniform acceleration. In this case, we say constant, and it really just means it is unchanging. It's one value. So it's unchanging. That's what uniform means. That's what constant. So when you see like constant acceleration or uniform linear acceleration, all it's saying is the acceleration does not change value. And when the acceleration does not change value, there are three equations that we can use. We can use final velocity equals my initial velocity plus my acceleration times my time. Some of you who are really good at math will look at that and say, oh, that's our acceleration equation rewritten. Because if I have A equals VF minus VI for t, I would cross multiply and get acceleration times time equals VF minus VI. And if I'm solving for VF, I add VI to both sides, add VI to both sides, and VF would just equal VI plus AT. So that is the equation, just our acceleration equation rewritten. Another equation that we can use is F squared. So final velocity squared will equal my initial velocity squared plus 2 times my acceleration times my distance. And the last equation we can use, which we actually tend to use a lot, is distance equals my initial velocity times my time plus my acceleration times my time squared divided by 2. I like to write it like this because sometimes when you have the 1/2 in front, some people get confused on what to do. Not entirely sure why, but that's what people get confused by. So, and one thing that I cannot stress enough is remember this. Please remember this. Year after year, student after student will write this equation down, and they will forget the times or square their time. So that's really critical, because if you don't square your time, you're going to get the wrong answer. Okay, let's use this for an example and we'll be done. In my example, I have a seagull drops a clam to crack it open on the pavement. This is actually what they do. They go find clams, they pick them up, and they literally fly high in the air and drop them so that they can break the clam open so that they can get the meat on the inside. So, and this is actually a Regents physics problem. A seagull drops a clam to crack it open on the pavement. The clam takes 3 seconds to fall. How high in the air is the seagull? Remember, you should be copying down this problem into your notes. So, let's do LEPA. Let's follow LEPA and figure out what we have and what we need. So, one is they're asking how high in the air. So they're asking for our distance. How high is the seagull, right? A seagull drops a clam. Oh, it drops a clam. So if it dropped the clam, just like you did in the acceleration lab where you drop the tennis ball or drop the golf ball, your initial velocity is 0 meters per second. The clam takes 3 seconds. Okay, that's time. Time equals 3 seconds. And then some of you say, Mr. Hunter, this problem doesn't give us enough information. And I would say lies and shenanigans, because the seagull has to be flying on planet Earth. Unless they tell you where you are, or if you're on an unknown planet, assume that the planet is Earth. And as I just showed you, the acceleration due to gravity on Earth is 9.8 meters per second squared. Okay, so that was the L part. The E part is, let's go look at those three equations. What equation has distance, initial velocity, time, and the acceleration due to gravity, or acceleration in it? And hopefully your answer by this point is D equals VIT plus AT squared divided by 2. So that's the equation I'm going to use. If you're not sure how I did that, pause the video and go look at your reference table and look how I picked that, because some of you are still struggling with listing all your variables and going to pick the right equation to use. So lastly, I plug in. So I don't know distance. 0 times, I can put in the 3, but anything times 3 is 0. Plus, and I'm running out of room, 9.8 times 3 squared, all divided by 2. So distance equals that. I don't have a calculator, so I'll be doing this math in my head. So 9.8 divided by 2 is 4.9. And then 3 squared is 9. So then I have 9 multiplied by almost 5. So that would be 45. So my answer is probably going to be a distance of 44.5, maybe, approximately, meters. And that would be my answer. So notice I followed LEPA. I list my variables with the units. I listed the equation I needed. I plugged in and solved, and I got an answer and circled it. And if you notice, it didn't take me too long to do that. So I will be checking this tomorrow. So make sure you have this done.